meeting. It's my pleasure to give the word to Vasily Ivanovich Pekhnyo, who is a corresponding member of National Academy of Sciences, representing the Institute of General and Inorganic Chemistry. And he will say you the names of his presentation. Thank you.
Где самый пульт? Уважаемый председатель, присутствующие коллеги, спасибо за возможность.
Dear colleagues, thank you for this opportunity. We'll tell you about some of the developments in medical chemistry and in particular the new biologically active substances that can be applied as methods to treating some of the tumors. This is joint work of 3 institutes: General Chemistry, Experimental Institute of Pharmacology. The human being is an integral part of nature, so therefore all the components and all the chemicals are located in the body. So we can define some of them: organogenic, there are 6 elements, and metals of life that are located in our body, 2.4%, and organogenic 97%. It's clear that normal concentration provide normal function of the body. The excess or the lack of some elements may cause certain diseases. Chemists, pharmaceutics, and medical practitioners have learned to treat classic diseases that are inherited by the nature: typhus, cholera, TB. But there are other diseases, technogenic, that are caused by the intrusion of a human being into natural processes and the new technological processes that were not in the nature before, changing in the climate, environment, and of course professional diseases that the medics have learned, some of them, to cardiovascular, AIDS, and oncological. The latter ones, according to WHO, takes the 2nd place in mortality and morbidity over the year. Every year, which is statistics, 10 millions of people every year find that they have some tumors. In Ukraine in 2012, 961,000 of oncology patients were registered in Ukraine. Of them, 38,000 men and 652 women. Every year, there were 160,000 people, citizens, who know that they are suffering from tumors. Every 1,000 children each year are diagnosed with cancer. 90,000 citizens statistically are dying because of tumors. And naturally, the treatment of tumors depends on diagnostics. The earlier it is, the more efficient the treatment is, and the applied treatment methods. Basically, with early diagnostics, 70% of adults can be cured. Of 10 patients, 7 are cured. In Ukraine, 4 or 5. And this is some demographics of oncology, various age groups. So this is statistics. Basically, the methods of treatment, there are 3 methods: the chemotherapy, the radiotherapy, and extreme method is surgery. We work in the medical chemistry and chemotherapy. The arsenal of medics is rather huge and has a huge number of chemicals, synthetic materials, and medicines that are prolonging the life of such patients, and in such cases cure them. But they are only effective if they're not toxic, if they don't damage liver and if they are targeted, if they target certain organs, and if they're selective. Selective if they are absorbed by tumor cells. So cisplatin is very toxic. It damages kidneys and liver. It's not selective. It's not targeting. It doesn't spread over the body, and it's not consumed by tumor cells. So our task is to obtain new substances that are much lower total toxicity. They are targeted action, selective action, and there's no acquired tolerance of the body. Cisplatin requires the dosage to be increased because the body develops a tolerance, but it damages the liver and kidneys. The more you have it in the body, the more damage to the body. And the new methods, if boron cells get into the tumor cell, radiotherapy, some sort of nuclear reaction occurs. Cesium particles and alpha particles that burns the oncocell from within. As I said, we work in the field of development of new substances for treating the tumor, the cancer of tissues and bones. Because there is no medical there's no medicine that would be selectively treating the bone tissues. There's just general medicines that relate to indirect improvement, but they are not selected and they are not targeted. We focused on palladium compounds because palladium also has anti-tumor properties, just as platinum and cisplatin. But according to literature data, we know that palladium is less toxic than platinum. It's because palladium builds less strong binds with DNA than platinum, and it's quickly washed off from the body. But at the same time, it has anti-tumor properties, and palladium is cheaper than platinum. So we decided to join with diphosphone amino acids. The diphosphone quality was to synthesize many toxic substances of addressed activity and selective action. So therefore we took diphosphone as transport agent, which uniting with palladium in the compound will deliver it in the bone tissues. Why? Because diphosphone acids are analogies of pyrophosphorus acid. And we thought that they will transport the same way. The second reason is that right now in the world there are 12 medical substances produced by Novartis, Procter & Gamble, Bayer, and other developers, and one of those assets is produced as Mebifone by Pharmac company. And one of the authors is Sergei Vasilyevich, present here. And another medicine is Medivit, which is for treating the bone tissues. And all these compounds are used to treat non-oncological diseases of bone tissues. So diphosphone acids will deliver it to bone tissues, palladium to bone tissues, and then there it will act as an anti-tumor agent. And these have also indirect anti-tumor effect. And the last thing, azidronous acid, it has antitumor properties and recommended for treatment in Western Europe, and oxyartin diphosphone acid is recommended in the US for treatment of cancer of breast cancer. We have listed the new characteristics with these diphosphone acids. Some of them are produced individually as a pharmaceutical. We have done physical chemical characteristics. The details, I will skip some of them because there's no time. We have established how the diphosphone acid is bound with palladium by what atoms, and how the biochemical properties of these substances changed depending on diphosphone acid and its replacement. We have studied the states of these coordinational compounds in solutions because it's important to use these substances in infusions or injections. Depending on pH environment of the body, it's from 6.5 to 6.5 pH. So it's important for us what is the form of this compound. When changing pH, we observe different degree of proteinization of the system, which doesn't participate in the bindings with palladium. And depending on pH in the solutions, we can observe various anti-isometers of these compounds. And the methods of structural analysis, the crystalline structures changed, which is important for the different types of packaging, whether tablets or suppositories. And the only difference in the solutions is that deproteinization differently occurs, and crystals form various intermolecular hydrogen bonds. In order to increase the concentration, the possible concentration of palladium that will have antitumor properties, we synthesize and characterize a compound which not only contains palladium but also copper, cobalt, nickel as model. And furthermore, we synthesized a compound which has 3 atoms of palladium: palladium calcium, and palladium cadmium, which is also important for bone diseases. What are the practical properties? What we have achieved as a result? These studies have been done in vivo and vitro, when we established that our compounds and their efficacy practically are the same as cisplatin, a reference compound in Ukraine, and as for lympholucosis 1210, and they are no worse in activity than cisplatin. Now, toxicity. We have established that toxicity of our compounds is almost 10 times less than cisplatin, or an indicator LT50. Have we provided targeted action in the bones of experimental animals? There's a test of creatinine and urine in the serum, natrium chloride. A different group of animals with cisplatin and platinum compounds. And the third group of animals where we had, which were treated with our palladium compound. The creatinine and our compound does not change, but cisplatin leads to formation creatinine and urea, which proves that there is a kidney damage. So our compounds are as effective as cisplatin, but they do not deal any damage to kidneys. The same was shown by resection of liver and kidneys of tested animals, and we also have established that our compounds are selectively accumulated in the bone tissues. No other existing pharmaceutical have no such selectivity for bone tissue. So these compounds are targeted. So it's a third goal that we set forth. What does it give us? It gives us the possibility to use them to treat oncology of spine because they are selectively aggregated there. For treating, we have people who have tumors in will have breast cancer or other glands cancer. They cancer metastates to the spine. So to localize the metastases in spine, these compounds also can be effective. We treated melanoma B16, and after resection of the leg, we observed metastasis to the lungs, metastasis to lungs, and after treatment. And the study that we did together with Belarusian Institute of Physics, we established that introduction of our compounds to the abdomen leads to disappearance of metastases in lungs. Compared to reference cisplatin, we have the comparison here. Our compounds remain with the time; they don't wash out. There is no tolerance developed by the body because the diphosphone characteristic is established. They are equal in their efficacy to cisplatin. They are 10 times less toxic in the general toxicity. They do not target liver and kidney and other organs. And of course they're more affordable because platinum is way more expensive than palladium. And we assume that we can achieve the full selectivity of the because phosphone acid will deliver the substance to the bone, whereas folium acid will provide a selective diffusion of this agent by the tumor cells, because experimentally we established such infusion. So this is 3 items, which explains the better efficacy. And the metastases to the spine are accompanied by the same characteristics as the calcium is washed out and the magnesium is washed out. So we synthesized palladium, calcium, and magnesium contained the phosphonates, which should act as anti-tumor and anti-reduction property. Our plans for the future, we will try to synthesize complex compounds of palladium and calcium with all diphosphonic acids to investigate their composition, and uranium containing diphosphonates because there are 2 isotopes of uranium which are more effective than the currently applied radioisotope. Their half-life is 3 to 6 hours, and they have better emissions. And this is our team who participated in doing this work, the chemical part of this work. Thank you.
Only one question, please, because we are out of time.
So we have a complex which moves toward the target. Is it important that this complex have to be